Alright, so I'm going to be doing exercise 1.10 in inequalities and exercise 1.11 absolute values of the math tutorial. So 1C and F, okay? Now 1C states that, is negative infinity an element of minus infinity to 3? That's 100% correct, right? Because minus infinity is one of the things in the brackets. Now we're doing F. Is 7 greater than or equal to 7? That's 100% correct. 7 is, it's not greater, but it's equal to 7. 7 is greater than or equal. So remember, it's or equals to. So it can be greater or it can be equal to, which in this case, it's or equal to. Now, the next question, what is G? Okay. So now G over here. Okay. So is a set 2 and 5 equal to 3, 2, 3, 4, and 5? That's wrong, okay? Because you have to see that 2 and 5 is not equal to 2, 3, 4, and 5, okay? Because obviously it has to just be equal to 2 and 5. Now the next question, do 2, okay? 2. Okay, so 2. Now sets A and B are given that A is that, B is that. Okay, find A. So what this question means, A and natural numbers. So basically this thing, in all the natural numbers in A, you must give it, right? So natural numbers are any number from 1 to infinity, right? So in this case, it'll only be 3. What is B and Z? So it's all the integers in B. Now if you look at B, the only integers I see is 0, and 4, 0 and 4. Those are the only whole numbers. Otherwise, you're getting decimals and stuff, yeah? Okay, so that's nuts. Then C, B, and rational. So rational numbers are any numbers that can be represented as a fraction. Is 0 rational? Yeah, 0 is rational. No, but 0 you can't represent it as a fraction, huh? 0, 0. Okay, so I'm not sure what this 0 is rational. Yeah, I think 0 is rational. Because 0 under the square root sign is 0, okay? Also, it has no decimals, right? Now, minus 1, that's rational, okay? 3 is rational. Square root of 4 is rational, but that'll produce 2. 4 is rational. And minus 3/4, that's rational. Perfect. So the next question is D. What is A and B? So basically they're saying all in A and all in B. Look at it and find some stuff that is common between the two. So A has minus 1 and 3. So look if it has minus 1 and 3. And B, that's perfect. So A and B is equal to the set minus 1 and 3. Okay, so X equals 2. So this is a set. But obviously now this set cannot be written. So describing the set, which we have to rewrite the set, right? So X is equals to, X is an element of B. So X over there is an element of all of B, and X squared is equals to X squared is an element of A. Okay, so what this means is that X is an element of B, such that X squared is an element of A. X is an element of B such that X squared is an element of A. Okay, so choose one number from B, right? And if you square it, it must be an element of A. That will be one of the numbers in the set E, okay? So let's say B. B is 0, right? 0 squared is 0, which is not anything in A, okay? You have to get minus 1 and 3, right? Minus 1 squared, that is 1, okay? That's not any elements. 3 squared is 9. Root 2 squared is 2. Root 4 squared is 4. Minus 3 squared is 9. 4 squared is 16. So I mean, X squared is an element of A. Yeah, there's nothing, huh? I think it's an empty set, yeah? Because every time you square in B, you're not going to get minus 1. Firstly, you can't get minus 1 if you're squaring anything. Because when you square something, it'll always be positive. And we need to get 3, huh? 3/4 squared, what's that? 3 squared is 9 over 4 squared, 9 over 16. 9 over 16, that's not equal to 3. Okay, so I don't think there's any over here. Okay, so there's none. So this is the empty set. Okay, so the next one we're doing 3h and k, right? H and k. So it's these two over here, right? So 3h. So x minus 2, right, can be written as x minus 2 and x minus 2, right? That's why they have square, because x minus 10, x minus 2. But already, I mean, we don't need to do that. X minus 2 is already simplified, right? So all we have to say is this. X minus 2 squared is equal to 0. So x is equal to 2. So x is equal to 2, right? Because think about it. When you put 2 in x, it'll be 2 minus 2, which is 0. 0 squared is 0. So x is 2. But this is a critical value now. What we need to do is draw a number line. 2 will be somewhere over here, right? 2. Okay, so x minus 2. Now, you can do a lot of ways now. I told you there's a lot of ways to do this, right? You can plot one number and see what's positive. Okay, so all those numbers in the right of 2, right, will be 3, 4, 5. Let's put one of these numbers in the equation. So let's say 5, right? If you put 5 in place of x, it will be 5 minus 2, that's 3. 3 squared, that's 9, that's positive. So all these numbers will be plus. And if you go on the left, let's say 1. 1 minus 2, 1 minus 2, 1 minus 2 minus 1, oh, so it's 1. So it's also positive. So hold on, yeah, there's something happening here. Yeah, okay, so, I see. So any equation squared, it has to be positive, okay? They can't be negatives. This is a trick question. So see, so now they're looking for negatives. I mean, there is no negatives. So there's no solution here, right? Because think about it, anything squared will always be a positive. But here it's asking what value of x will make it a negative. You can't. It's an empty set, okay? You can't do that. So you can say there's no solution. They can give you an answer, maybe a reason. X, anything squared. So you can say x squared cannot be, less than 0. But see, the other thing, less than and equal to 0. And it can be equal to 0, right? So, and in that regard, you can say it equals to 2 only, right? So our first answer was right. Because 2 minus 2 is 0, 0 squared is 0. 0 is not less than, but it's equal to. So your answer will only be 2. But now you saw you can't do anything else, okay? So the next one we're doing is k, okay? Now k is already factored for you, but here's the thing, it's a trick question, right? You always want 0 on the right hand side. So what you do over here is simple. You multiply it out, right? Use FOIL, these brackets over here. So it's x squared minus 2x minus x plus 2. And then now we take the 2, which is over here, put it on the left, so that's minus 2. Minus 2, that's 2. X squared minus 3x, okay? X squared minus 3x will be less than 0. So now remove x as a common factor. That's x minus 3 less than 0. So x equals to 0 and x equals to 3. So 0 and 3, okay? 0 and 3. So now you got critical value, which is 0 and 3, right? So now put it in the number line. 0 will be here, 3 will be here. Told you to see all the look in the. Okay, so you want let's see. What was the thing? X squared minus 3x. Perfect. So anything above 3, let's see. So 5. 5 squared is 25 minus 15. That's 10. So that's positive. In between there, let's say 1. 1 minus 3, that's a negative. And let's any negative, let's say the minus 1. So minus 1 squared is 1 minus 3 minus 1. Let's see, minus 1, that's 1. It'll be negative, right? Perfect. So minus, no, wait. Wait, I'm not good at maths here. Mental maths is my weakness here. Minus 1 squared is 1. And then minus 3 minus 1 is positive. So it's positive. Okay. I'm not good at that math. So, okay, so they're asking where it's less than 0. Now remember our previous question, we had this. Okay. We came to this answer, simplified. So there is less than 0, negative. So obviously don't include it. So empty circle, empty circle. So it's in between 0 and 3. Okay. So you can rewrite x is an element of 0. So now we write around brackets going on including and 3. Okay. Perfect. So that's done. Okay. Now the next one is doing is I. Okay. I. So let's see I. Okay, so this is already factored for you. X times x plus 3 less than 0. Perfect. Critical values will be x is equal to 0. X is equals to minus 3. Next step, draw a number line. 0. Minus 3. Yeah, minus 3. Let's see. Minus 3, 0. Alright, perfect. So, put everything that is more than 0. Let's say 1. So 1 times is 1 is positive, yeah? Positive. In between minus 3 and 0, let's say minus 2. Minus 2 plus 3, it's positive. Negative, okay, minus. Then obviously it will be, let's say minus 5. Minus 5. Minus 5 times minus 5 plus 3. Positive. Okay? There will be plus, minus, and plus. Now they're looking where it's negative, right? So, and it's including. So shade in that circle, shade in that circle. So it's in between minus 3 and 0, but must be including, right? So this is how you write it, right? What 0 and minus 3 was, right? Okay. So x is an element of including 0, and it must be minus 3 first. Including square brackets minus 3 and 0. 0 is also included because it has an underline over here. Okay, so that's the x element of minus 3 and 0. Next question. What is 4j? 4j, 4j. Okay, 4j. Okay, so as soon as you see this, right, it might look complicated, but it's very, very easy. So now I need space, right? So 1 over 2 minus x. Let me rewrite it, okay? 1 minus 2 minus x. 1 minus over 2 minus x. Less than equal to. That's less than equal to. Okay, I never have space, so I rewrote it. Now, you may be tempted to do this, right? Say 2 minus x times it by negative 1 cross, but you can't do that because you do not know if x is negative, right? Because in x it can be negative, but you do not know. So we have to move the fraction on the left, make the right 0, okay? So it's 1 over 2 minus x. Bring the fraction to the left. So right hand the fraction is minus 1 over 5 minus 3x. Then that will make it plus 1 over 5 minus 3x. Okay? Less than or equal to 0. Perfect. Now we combine it, right? 5 minus 3x. So make the denominator an LCD. So 2 minus x goes 1 times. You're left with 5 minus 3x times 1. So that's 5 minus 3x. 5 minus 3x goes into 1 time. That's plus 1 times 2 minus x. So plus 2 minus x. Don't forget, less than or equal to 0. Okay, simplify. Minus 3x minus x, that's minus 4x. Plus 7 over 2 minus x. 5 minus 3x. Okay, less than or equal to 0. Now, 4x. Right. Okay, so now what to do is say this. I remember, you need to find where it's less than or equal to 0. If the numerator, which is the above fraction, is 0, then the equation will become 0. For example, 0 divided by any number, 5, will be 0. So, and now you have to look at the ones below it, because when the new denominator is 0, it becomes undefined, right? So first, let's look at the numerator, right? And let's make that equal to 0 or less than or equal to 0. So minus 4x plus 7 must be less than or equal to 0. Minus 4x is less than or equal to minus 7. And then change signs because you're multiplying by negative, dividing by negative. That's 7 over 4. Okay, 7 over 4. And obviously x2 minus 2. So x is equal to 2. It will make this over here 0. And 5 minus 3x. 5 minus 3x to 0. Minus 3x is equals to minus 5. X is equals to 5 over 3. Okay, so x cannot be 2, x cannot be 5 over 3. That's a restriction, and x must be greater than 7 over 4. So represented as a number line, you represent first 2, then you put your undefined, u, just put u. Then 5 over 3, that's like 5 over 3. That's like over here. 5 over 3. It's also undefined. Then you got x is equals to greater than 7 over 4. So 7 over 4. Somewhere over here. Okay. Alright, so just ignore the previous number line. It was very confusing, so I rewrote it. Alright, so I told you 5 over 3. What we got? These are the undefined over here. 5 over 3 and 2. So 5 over 3 and 2 is undefined. But check. Now we got our number line. Now to get plus there, minus here, plus here, you put values. So if you put like something less than 5 over 3, like example minus 10, you get a positive, right? That minus 10, you put it in your equation over here. Then you get a positive, so that's plus. If you put any number between 5 over 3 and 7 over 4, you get a negative answer. If you put any number between 7 over 4 and 2, you get a positive. And then you get a negative, any number above 2. So now the equation here is less than or equal to 0, so negative. And is it including? Yeah, it's including, okay? So 5 over 3, but you cannot include 5 over 3 because that's on that point, it's undefined, right? So it's an empty circle, and you can include 7 over 4, okay, shading that circle. And where else is negative? Over here, we do not include 2 and infinity. So your final answer will be x an element of 5 over 3 to 7 over 4. Okay. Or now to represent or, you put union, another set, 2 to infinity, positive infinity. That's your answer. Okay, so the next question, 7a, show that if x is in between 0 and 1, then 0 is less than x squared, which is less than x. So this equation, 0 less than x squared less than x, you can rewrite it as this, right? 0 is less than x squared, okay? And then you can rewrite it as x squared is less than x. Now to do this equation, you have to substitute a value. So what value is in between 0 and 1 over here? Half. Let's put half, right? So now we just half. So what is half? Now the thing is 0 is less than x squared. Okay, let's prove that, right? What is x squared? We chose x is half. That's 1 over 4, which is true. 0 is less than a quarter, right? Because 0 in the number line is the quarters over here. That is true. And then x squared is less than x. Quarter, which we found x squared is less than half. That 100% makes sense. So therefore, that is 100% correct. Okay. Next one is B. Okay. Show that if x is greater than 1, then x squared. I mean, see, this is simple stuff here. You just substitute values, right? I have x is greater than 1. So let's pick 5. So 5 squared is 25. And 25 is greater than x, which was 5. So I mean, you know, you just substitute values. It's called proof by contradiction. You substitute that. Okay. So we've done with inequalities. Now the next part video I'll do absolute values.